Okay, welcome once more to another new video on the Maths Youth Academia, also called the MYA. So today we shall look one question on limit, which says that show that the limit of z to infinity of 1 plus 1 on z raised to the z equals to e. Okay, then now the first step, I'll now let k, or let a certain letter to be equals to my limit. So I'll let any letter of your choice to be equals to my limit. The second point, now I'll just multiply both sides by ln, The third point, I'll apply the law of exponential, the law of logarithm. So my z will cross. So I will now have ln of z infinity z ln 1 plus 1 on z, all in brackets to 1. So 1 there doesn't change anything there. Then now I have my ln k to be equals to what? Remember that this one and this one here doesn't change anything in the equation. So where I have z, I'll just substitute infinity there. When I substitute infinity z in bracket ln, I have 1 on infinity. 1 on infinity is typically 0. So I have 1 plus 0, which is 1 there. Then now ln 1 is 0. So infinity times 0 from there doesn't make sense now. So now so now from there you can now use L'Hopital's rule. The fifth point, now I have ln k to be equals to my limit as z tends to infinity. I have now what? Remember that from point 2, right? I have ln k equals to ln z on infinity z ln, on in bracket 1 plus 1 on z raised to the 1. Then now ln k is equals to ln z to infinity ln 1 plus 1 on z 1, all divided by 1 on z. Then now 1 on z is the same thing as ln z, same thing as limit of z times ln 1 plus 1 on z. So if I'm trying to simplify it here, so how have I done to have limit of z to infinity ln in bracket 1 plus 1 on z raised to the power 1 divided by 1 on z? I've just remember that from point 3, right? From point 3 I have ln k to be equals to ln z ln 1 plus 1 on z raised to the power 1 z tends up to infinity. You can see that it can be all on one. It can be all on one, right? It can be all on one. So now since I have my limit on 1 is the same thing, because something divided by 1 is still the same thing, right? Then now I now decide to multiply. It all through by 1 on z. And now multiply all through by 1 on z. This z here will cancel this one here. This z will cancel this z from this side now. I now have 1 times 1 on z, which is typically the same thing that I have here in point 5. So now at this stage here now, it shall now be the 6th point. I have down ln k to be equals to what? To be equals the limit as z tends to infinity, z continues to infinity, right? So typically here I've used L'Hopital rule, right? Then now I've now differentiate the numerator and the denominator. When I differentiate the numerator, I'm having what? I'm having this case here. divided by when I differentiate the denominator. Remember that when I differentiate the numerator, I've used chain rule. Chain rule, that means what? I've let, maybe when you are seeing this ln, all in bracket 1 plus 1 on z, right? I've let y to be equals to ln, all in bracket 1 plus 1 on z. Then now from there, I've now let another letter like a to be equals to 1 plus 1 on z, and now differentiate the two equations. Then I've used now product rule. I've multiplied. When I let remember that I've said that here that I've let ln 1 plus 1 on z be y now, and I've let this inside this function of ln to be any letter of your choice like a. Now y will now be equals to what? Ln a. When I differentiate ln a, I'll now have what? 1 on a. I'll have 1 on a. Then now when I differentiate now a, I'll have what? 1 minus 1 on 1 minus 1 on z2. Then I'll multiply now both of them, because I'll multiply both of them, because when I differentiate now the a part, I'll have minus 1 on z square. Then now when I've let y to be equal to ln a is what? 1 on a, right? 1 here on a. This a here, remember that I've now inside my function, I've substituted a there. So when I've seen when I have a there, I substitute just this function that's inside here times now the a that I've differentiated, divided by, now I've differentiated now the denominator. I have now minus 1 on z square. Okay, the certain point now, remember that from point 6, this point here will cancel this point here, so this one will go off. I'll now remain now with this part here. I have now ln k to be equals to 1 on 1 plus 1 on infinity. Remember that I've substituted where I have z here, I've substituted infinity there. Infinity. Remember that 1 on infinity is 0. The 8 point now, ln k is equals to 1. Why? I have 1 on 1 plus 0, which is 1. The 9 point there now, in order to find k, I'll just take e on both sides, right? I'll just take the e on both sides. I'll just take the e raised to the ln k equals to e raised to 1. So I'll just take the exponential, the e exponential on both sides of both equations. Remember that from logarithm or exponential, e to the ln k is basically k. And e to the raised to the power 1 is e. Right? Let me come again. From the 9 point, I have e raised to the ln k equals to e raised to 1. From the law of logarithms, e ln k, remember that I have e ln k, right? E ln k can be written as what? Log k base e. Then now e log k base e, I'll just take this thing, the power, the k. So ln k can be written as what? E, let me write it clearly. Ln k, sorry for my handwriting, can be equal to log k on e, so the e, and then now equals to e to the 1. Then now k now will simply be e here. Simply be e. So that was just all about it. And then now from now there, you have now it as required. Okay, thank you for watching the video. Please, if you want more, just go to YouTube and just go to YouTube, to the YouTube app, and just um, uh, um and just see the Maths Youth Academia on bracket the MYA. So basically in this channel we are solving different type of question, and you have any issues, just post it in our channel for us to help. Please don't forget to subscribe, comment, post questions and share. Have a nice day.